UALR College Algebra Final Exam Review. We're going to try to work out problem number 52 and 53 on this video. It says solve the exponential equation algebraically and approximate the result with 3 decimal places. So here we have an exponential equation. We are going to use the logarithmic form of that. We're going to say that log base 7 of 2x, or sorry, of 40, equals 2x. We're going to divide that by 2 on both sides. So we're going to x equals log base 7 of 40 over 2. Now you can enter log base 7 of 40 on your calculator. This calculator that I'm using, we have to use that change of base formula. So I'm going to end up doing ln 40 divided by ln 7 all over 2. So I'm going to type that in the calculator because I don't have that new operating system on here. So I'm going to get, let's see here, clear that. ln 40 divided by ln 7. I'm going to go ahead and hit enter there, and then I'm going to divide the answer by 2. So I'm going to get 0.948. Which makes sense because 7 squared is 49. And so you would expect that to be close to 7 squared, but that'd be close to plugging in 1, but not quite. So that makes sense. 53 says solve the logarithmic equation algebraically and approximate the result to 3 decimal places. If there's no solution, enter no solution. Here I have log base 7 of x plus log base 7 of x plus 6. I'm going to look back at my properties that we talked about a few minutes ago, specifically this property, where if you have 2 logs, same base added together, I can bring them together in 1 log with a product. So I'm going to say this is the same as log base 7 on the left side of the equation now. I'm going to multiply x times x plus 6 and get x squared plus 6x. And that's going to equal log base 7 of x plus 24. And now we're back to that one-to-one property we had for exponentials a few minutes ago. We got log base 7 operating on x squared plus 6x, and that's equal to log base 7 operating on x plus 24. To make that true, then x squared plus 6x has to equal x plus 24. So we can just cancel the logs because they're the same base. So x squared plus 6x has to equal x plus 24. This is a quadratic equation, so I'm going to get everything equal to 0. I'm going to get x squared. I'm going to subtract x and get plus 5x, and then subtract the 24. So now I need to find 2 numbers that multiply to make negative 24 and add to make 5 if I'm going to factor this, or I could plug it in the quadratic formula. This will factor because x plus 8 times x minus 3 equals x squared plus 5x minus 24. So x has to equal negative 8, or x has to equal 3. When I go back to my problem, if I plugged in negative 8 here, I would have 7 raised to a power equal a negative number. That can't happen. Negative 8 is what we call an extraneous solution because when I plug it back in, I get an undefined logarithm. But if I plug in 3, I can get log base 7 of 3. I can get log base 7 of 9. I can get log base 7 of 27. So all those are good. So x equals 3 is my only solution to that problem. So that's how we do number 52 and 53.